100 Lessons on Physics for the Next Einstein. Series Introduction, a new series on foundational physics. The universe is a paradox. The most amazing thing about our world is that it is a paradox, in every sense of the word. We truly believe this, and it is not just a catchphrase. Despite a lot of scientific progress, especially for the past few hundred years, there are still so much we don't understand about the universe that we live in. One of the most important goals of this series is to spread the joy of wonder about nature. So, what exactly is this about? Our goal is to promote a different way of doing physics to the broad audience. For that, we will cover some absolute basics of physics, mathematics, and philosophy in this 100 lesson series for the next Einstein. Incidentally, these are not really lessons. They are more like stories, and they are really designed to stimulate your further thinking. We are all about questions, and not necessarily about answers. In fact, we do not generally provide answers in these lessons, although it may seem somewhat strange. So, who is the next Einstein? Are these lessons for me? Who is this for? These physics lessons are open to anyone, of course. But we use the name Next Einstein to refer to a person who is more open to unorthodox and contrarian views. Because that was exactly what Einstein stood for. In fact, Einstein was never part of the mainstream physics. That is, to us, Einstein represents an independent and original thinker. That's the next Einstein. Einstein was a true rebel who refused to do physics in the way directed by the authorities. Some 300 years before him, Galileo was also a rebel, who defied the authorities of the Catholic Church and the Aristotelian scientific dogmas. In our view, that is ultimately what doing physics is all about, that is, understanding nature in our own way. Foundational Physics. This Physics for the Next Einstein video series is an ambitious project with a long-term commitment. Hope you will find this series rather interesting and ultimately helpful in learning and enjoying physics. In this project, we are primarily interested in the foundations of physics, sort of low-level physics, which intersects with philosophy. This is a rather niche area outside the mainstream physics, where there is little career opportunity, if that is why you are interested in learning physics. Some fundamental questions in foundational physics. As an example, here are some of the fundamental questions in physics and philosophy that we are particularly interested in. The fundamental nature of space and time, and classical and quantum fields. A deeper understanding of gravitation. Gravity and space-time and matter fields are all coupled in some way, and we do not yet know their interactions at the fundamental level. The origin and evolution of our universe, and its ultimate fate. What is reality? Locality? What about causality? And so on, which are really metaphysical questions. Foundations of quantum mechanics, such as the measurement problem and quantum entanglement. Due to the recent growing interest in quantum computing and increased public funding and private sector investment, this particular area of foundational physics seems to be getting a little bit more attention than in other areas. Branches of physics. To give you a general idea of what we are going to cover in this series, we will primarily focus on the following subjects: special relativity and general relativity, modern Big Bang cosmology, foundations of quantum mechanics, quantum information theory. On the other hand, we will ignore pretty much everything else, including quantum field theory, high-energy physics, and whatnot. So, what exactly are we doing? We will present the stories, more or less, following the historical development. Starting from the ancient Greek philosophy to the 21st century modern physics. This is mainly because our current understanding of nature is built on the preceding development, which was in turn built on the even earlier development. Otherwise, we focus mainly on space and time and our Big Bang cosmos in the first half of the 100 lessons, and our focus is mainly on quantum reality in the second half. We will generally prioritize breadth over depth in each story. That does not mean, however, that the topics and the levels of discussion will always be high level. These lessons are more like a self-study guide, rather than traditional classroom lectures. Nonetheless, we are putting in a lot of effort to provide enough details. The motivated viewer can go much deeper with the provided information. As a matter of fact, that is one of our primary goals, to stimulate the viewer's interest in physics, rather than to just teach. In general, the lessons in this series are, and will be, created with a broad target audience in mind, with wide-ranging background. Different people will get different things out of these lessons. To help them gauge the difficulty levels of different lessons and their parts, we will use the following 4 labels to indicate difficulty levels: G, N, M, and E. These labels stand for Galileo, Newton, Maxwell, and Einstein respectively, 4 of the most influential physicists in history, and they roughly correspond to easy, normal, difficult, and more advanced. But alternatively, they can be viewed as representing the nuttiness levels. That is, for example, the lessons marked as E will include more contrarian views in addition to the fact that they may cover more advanced or unusual topics. G for Galileo, for general audience. N for Newton. This is the standard target level across all lessons. Roughly speaking, this level will generally correspond to the college freshman to junior level for physics majors. M for Maxwell. We include some advanced topics for the viewers who are more math-inclined. And last but not least, E for Einstein, indicating extra nuttiness, if you will. The Einstein-level stories are not necessarily more difficult than others. They are just extra nutty. Stories and not lessons. As stated already, these videos are designed to provide general guidance and directions, and they are not intended just for watch and learn, like the vast majority of other education videos. You will get the most out of these lessons when you are actively participating. Ultimately, you will be the one who do physics and enjoy figuring things out for yourself. Remember, you are doing this for nobody else. Not for fame. Not for a job. Not for money. You are doing physics for fun. The joy of discovery. The lessons will cover essential physics and mathematics, as well as some philosophy, from the ground up, to the extent feasible. The only prerequisite is curiosity and a sense of wonder. Everything else you can figure out for yourself with some effort. Hence, that is the theme of our new physics lesson series. Curiosity and the joy of discovery. The joy of figuring things out. We borrowed this slogan from the book The Pleasure of Figuring Things Out by Richard Feynman. Learning and acquiring knowledge is fun and necessary, but in physics, figuring things out for yourself and solving puzzles for the first time can be even more fun. Knowing versus understanding. Learning and doing physics should be fun. You can do physics however you like. You don't have to be constrained by other people's ideas of what physics is. Physics is about wonder about nature, and it is not about how much you know. As long as you have a genuine curiosity, physics will be fun. Some nutty questions. To give you some general ideas as to what you can expect from these lessons, here are some random questions. We will not go through each of these questions. You can pause the video if any of the questions interests you. René Descartes, one of the greatest early modern-day philosophers, famously asked why there was something rather than nothing. Why do you think the universe exists? Time travel has fascinated us ever since H.G. Wells' science fiction novel, The Time Machine, was published in 1895. Do you suppose that time travel is possible in some way? People say that time is relative, according to Einstein's special relativity. Do you know what that means? The current standard model of cosmology is based on the Big Bang hypothesis, which is presumed to have happened some 13.8 billion years ago. Do you think that that was the beginning of our universe? Or do you think the universe existed before the Big Bang? Quantum entanglement is one of the most widely used phrases in popular science books these days. Do you know what it means? In your view, what do you think is the biggest mystery of our universe at this point? Have you heard of the Fermi paradox? Do you think there is an intelligent alien life out there? Do you think that the electron is a truly elementary particle, in the sense that it is not made of anything smaller or more fundamental? Why is the universe expanding? By the way, why is not generally considered a scientific question. You can read it as how or in what way if you'd like. But we do ask a lot of why questions in this series. Do you think you have what it takes to be the next Einstein? Are you allergic to either philosophy or mathematics? One thing we would like to emphasize from the outset is that we discuss real physics and real philosophy and real mathematics, although we tend to emphasize unorthodox and contrarian views. These physics lessons are not for the crackpots. What's next? Just to give you some concrete ideas, here are some of the lessons we will cover in the beginning. Story 1. The biggest discovery in the pre-scientific era. Story 2. The question that started the philosophical revolution in ancient Greece. Story 3. Why do we live in the circular and spherical world? Story 4. The Pythagoras theorem is not about triangles. Then what is it about? Story 5. The debate of the millennium that shaped Greek natural philosophy. So, are you interested? The beginning of a new adventure. This will be a real challenge in the best sense of the word, regardless of where you are coming from. Hope all of you can join us in this rather unusual and truly unique journey into foundational physics. And lastly, here's a book recommendation if you haven't read it yet. The Character of Physical Laws by Richard Feynman. The video of real lectures, which the book is based on, is also available on YouTube. Now let's get started. See you all in the first lesson.